the updated science on sea level rise, which is fairly recent, that we've understood this so well, and ice melt, and the implications of that for Hinkley Point C, and then a brief look at Sizewell C as well, and then a brief look at what might happen if a nuclear station were actually to be flooded, and finish off with a reminder that it's not just operating nuclear reactors that we need to worry about. So this was a Freedom of Information request that was made by the famous Rob Edwards in 2012 and eventually found its way into The Guardian. This was the analysis that was carried out by the government on the potential for flooding of nuclear sites. And you can see, if you look in detail at this rather complicated chart, that actually 7 out of the 8 sites that are currently deemed suitable for new large nuclear power stations were thought at the time to be vulnerable to flooding. The only one that wasn't at high risk was Wilver on the island of Anglesey. This map goes into a bit more detail, and you can see there, for instance, that there's a high risk of flooding at Sizewell in the 2010s. Bradwell, it waits until the 2080s before there's a high risk, and Hinkley, there's a high risk in the 2080s as well. And some of the other sites like Heysham in Lancashire are relatively low risk, and no risk at Wilver. But that was 2012. Since then, there's been a lot more work done on sea level rise, and this NASA study was carried out in 2018. They used a data set from satellite images and realized that sea levels not only rising, but actually, I think Sally mentioned this as well, the rate of that rise is getting faster. So as we go on, the level of the rise each year will increase. So then we came to August last year when the IPCC report came out, or one of them, and they had various scenarios which showed that the likely level of global mean sea level rise by the year 2100 is somewhere between 0.28 meters and 1 meter, depending on the level of mitigation. But they also had a scenario 5 worst case outcome, which said that 5 meters by 2150 can't be ruled out. The global mean sea level rise above the likely range could be approaching 2 meters by 2100 and 5 meters by 2150 under a very high greenhouse gas emissions scenario. And that can't be ruled out just due to the huge uncertainties involved with ice sheet melting. So recent work shows that scientists have been underestimating Greenland's rate of melting, and there are huge uncertainties about Antarctica as well, and how it will respond to rising temperatures. That means that the sea level increase by 2100 could turn out to be much higher. The biggest uncertainty, of course, is how much we manage to cut carbon dioxide emissions, but judging by the report that Boris Johnson's publishing tomorrow and the plans to look again at fracking, it's not very easy to be optimistic that we're going to achieve some of these figures, some of these reductions in carbon emissions. The IPCC report that came out this week said we've got 3 years to reach peak greenhouse gas emissions if we're to have any chance of limiting future heating to 1.5 degrees above pre-industrial levels. The melting of the Antarctic ice will become rapid and unstoppable by 2060 under certain policies. That's what this graph shows. That's if temperature increases by 3 degrees centigrade. So we could have a sudden increase in sea level beyond 2060. Oceanographer Stefan Ramstorff from the University of Potsdam told the New Scientist recently that even under the most optimistic scenarios, a global net zero being achieved by 2050, a further 50 centimetre rise is predicted by the year 2100. So if little action is taken, we might actually see that increase to 2.5 metres by 2100 and 5 metres by 2150, as I've said. But he pointed out that even a 1 metre rise is quite catastrophic, and 5 metres on that timescale would be basically an unimaginable disaster. So what does all this mean for Hinkley Point C? Well, at the moment, it looks unlikely to open before 2027. That's the latest estimate. And given that its expected lifespan is 60 years, we're talking about Hinkley Point C being an operating reactor right up until 2087. So it's quite a long timescale that we've got to worry about. And then the spent fuel, unlike the existing reactors that we've got, spent fuel from Hinkley Point C is going to be stored on site rather than transported to Sellafield. And according to the Nuclear Decommissioning Authority, it could take up to 140 years for that spent fuel to be cool enough to place in their geological disposal facility, which they've still to find a site for and still to build. So the final core of spent fuel at Hinkley Point C could still be there in 22, 27. That's the 140 plus the 60 years of operation, so 200 years after 2027. But why should we worry about it when a 2.5 or even a 5 metre rise is below the Hinkley Point C platform, which is 14 metres above sea level? Well, the reason why we need to worry is it's not just the height of the rise in sea level that's important, but also the likely increase in storm surges. Sea level rise magnifies the frequency and severity of extreme sea level events, or ESLs. So a 50 centimetre rise in sea level could mean storms that used to come once every 1,000 years coming once every 100 years. And a 1 metre rise could mean that once in 1,000 years happens once every decade. And the plans for Hinkley Point C's flood defences were drawn up in 2012 or before. The safety case relied upon the UK climate projection of 2009, or UK CP09 as it's called. That was upgraded by the government in 2018 to UK CP18. So both of these were actually before some of the most recent information about the melting ice caps and at Greenland and Antarctica were properly understood. And a lot of experts thought there was no net melting likely in Antarctica. They've changed their minds now about that. So estimates have gone up from less than around 30 centimetres to perhaps more than a metre, well above the, well within the operating lifetime of Hinkley Point C. The Office for Nuclear Regulation is the people that we think should be looking at this and encouraging EDF to actually do some new projections. But EDF say their projections based on UK CP18 are broadly similar to those of UK CP09, so they're not going to make any changes. So rather than forcing EDF to go back to the drawing board, ONR have been saying to them that detailed studies of potential flooding on nuclear licensed sites are the responsibility of the licensees, in other words, EDF. It'll be monitored via the periodic safety review process, which is something that happens every 10 years. But of course, that won't happen at Hinkley Point C until it's been open for 10 years. And they've also said to us that it's not reasonable to expect licensees to consider every new scientific academic study that comes out once they've already started building. But on the positive side, the Office for Nuclear Regulation do have an expert panel, and they've now been producing some of the minutes of their meetings. They've done new assessments of they say new assessments of future sea level rise have suggested that the global mean sea level increase will be greater than previously suggested in UK CP18. That was only 4 years ago, remember? And there's a possibility that the rise will be on 2 meters, more than twice the upper value put forward in UK CP18. In 2019, the expert panel said, small changes to the UK storm systems can alter the height of the storm surges significantly, and the loss of a substantial portion of the West Antarctic ice sheet may already be committed, which could result in more frequent extreme weather events. Moving on to Sizewell C, there's a scientist called Nick Scarr who's been submitting to the Sizewell C public inquiry. He's been examining EDF's claims concerning coastal erosion, where they say that they think the site will be stable because it's protected by the offshore Sizewell Dunwich banks, sediment banks, basically slightly offshore. He's put in evidence to the Sizewell inquiry, which says that both of these claims are implausible and unrepresentative of a significant range of worst case conditions. So this is a picture of what happened at Fukushima. The consequences were clear from the tsunami. It can knock out electrical systems, disabling its cooling mechanism and leading to overheating and a possible meltdown and a dangerous release of radioactivity. Of course, there have been measures taken since Fukushima to make sure that there's backup electrical systems and so on. So perhaps a scenario like this is less likely than it would have been. But around the globe, 25% of nuclear plants are in coastal locations, and many of these were built only 10 or 20 meters above sea level at a time when climate change was barely considered a threat. The Institute of Mechanical Engineers says that UK nuclear facilities may need considerable investment to protect them against rising sea levels or even abandonment and relocation in the long term. So it's not just the danger of a nuclear accident, it's also the huge cost that could be involved in trying to protect some of these facilities on the coast. And finally, this was a slide that Katie, who's on the call, managed to produce with help, which we've hopefully we're going to be using that to persuade the Office for Nuclear Regulation to look in more detail at this. Nuclear waste stores and nuclear reactors will all be vulnerable to rising sea levels. So even if the operating reactor at Hinkley Point C is closed before sea levels and storm surges become a real problem down there, the closed reactor and the nuclear waste stores might still be vulnerable to flooding. Hunston A, for example, closed in 1990. That's on the coast in Scotland, just south of Coalport and Faslane. And they're still retrieving packaged wastes there, and they'll be doing that until 2030. And then by 2035, they'll start dismantling the reactor. That could take up to 25 years. So there'll still be stuff there on the coast at Hunston A until 2060. It gives you an idea of the huge timescales that are involved in nuclear reactors. And so you can translate that all to Hinkley Point C as well. Hunston B has only just closed. That'll take about 3 years to defuel, taking us to 2026. And after that, it could be left until 2080 or 2090 before dismantling starts. And there's an intermediate level waste store positioned between Hunston A and Hunston B as well, which could be there for 100 years or more. So the Stop Hinckley campaign will hopefully provoke discussions with the ONR, and we can see from there that their view is that spent fuel could actually be on site at Hinckley for 200 years. I encourage you to have a more detailed look at this when you get the slides afterwards. But that's all I wanted to say just now. Thanks.